Now, in this video, we're going to talk about kinetic energy. This one is the energy of motion. So this is the opposite of potential energy, where potential energy is at rest, kinetic energy is at motion. Now, this one's very technical, so we have an equation here to solve for it. And I'll show you the potential energy equation in just a minute. But kinetic energy equals half the mass times the speed squared. Okay, I'll repeat that one more time. Kinetic energy is half the speed, or half the mass, and the speed or the velocity squared. That speed is a very key indicator of the kinetic energy. Since it's squared, it changes the amount of energy. So if you're increasing your speed, your kinetic energy is multiplying by at a much accelerated rate, rather than just like doubled or such. Now, since kinetic energy is also a form of work, we can relate those two equations. Work is net force times the distance. That equals our kinetic energy. So we can have an equation that equals both of them, where it's our net force times distance equals 1/2 times mass times velocity squared. We can use that equation to help us out in various situations whenever we need to relate work and kinetic energy together. Now, like I mentioned before, this is potential energy. Here's an equation for potential energy. More specifically, gravitational potential energy equals the weight times the height. So whenever we need to figure that out, m is going to be our mass, g is going to be our gravity, and h is going to be the height at which it's located relative to the surface of the Earth. And that's all your energy equations.